Ever wondered how we could nudge individual consumers to make more environmentally friendly decisions, specifically in relation to energy consumption from their home heating and cooling systems? This problem presents a unique opportunity for a machine learning-based solution, and here's why. Firstly, the problem is quantifiable. We can measure the impact of energy consumption decisions on the environment and subsequently track the changes in behavior. Secondly, it's a problem that can be addressed at an individual level, making it feasible for a solution to be implemented and tested. Lastly, it's a problem that's growing in relevance with the increasing focus on sustainability and climate change. This project follows the CRISP-DM business understanding model. The problem is clear. How can we motivate individual consumers to make more environmentally friendly decisions regarding their home energy use? Success can be defined as a measurable reduction in energy consumption and an increase in the adoption of environmentally friendly alternatives. The output metrics selected include the percentage reduction in energy consumption and the increase in use of renewable energy sources. Several factors could be relevant, such as consumer awareness about environmental issues, availability and cost of renewable energy sources, and even weather patterns. The proposed solution concept involves using machine learning to analyze consumer behavior patterns and then provide personalized recommendations for making more environmentally friendly decisions. To validate this solution concept, a series of iterative experiments will be conducted involving data collection, model training, and testing. When it comes to system design, 3 key decisions have been made. First, a supervised learning approach will be used as we have a clear target outcome. Second, the model will be updated periodically to account for changing behaviors and conditions. Lastly, a trade-off towards model interpretability will be made to ensure that the recommendations given are understandable and actionable for the consumers. Just as with any project, there are potential risks in production that need to be considered. Training serving skew could occur if the model performs differently in a live environment as compared to the training environment. Latency could also be an issue, as real-time recommendations are crucial for this solution to be effective. Data drift and concept drift could occur over time, with changing consumer behaviors and societal norms. However, these risks can be mitigated with regular model updates and rigorous testing. To summarize, this project aims to tackle the problem of individual energy consumption by using machine learning to provide personalized, environmentally friendly recommendations. The expected impact is a reduction in individual energy consumption and an increase in the use of renewable energy sources, ultimately contributing to a more sustainable future. Designing the user experience for our product involves key AI-specific considerations. Our primary objective is to create a clear and intuitive interface for users to interact with the AI. This involves easy-to-understand inputs and outputs, making the system as user-friendly as possible. Transparency is another critical aspect. We aim to provide explanations of how the AI makes its recommendations, ensuring users have a clear understanding of the process and the rationale behind the suggestions. This not only builds trust, but also empowers users to make informed decisions about their energy consumption. Communicating uncertainty is another vital element. The AI will convey its level of confidence in its recommendations, allowing users to understand the scope and reliability of the suggestions made. This is particularly important considering the ever-changing nature of energy consumption and renewable energy sources. Lastly, we plan to establish feedback loops. Users will have the opportunity to provide feedback on the AI's performance and recommendations. This will not only improve the system's accuracy over time, but also ensure the product evolves to meet users' needs and preferences. By focusing on these aspects, we aim to create a user-friendly and effective product that not only helps individuals to reduce their energy consumption, but also contributes to a more sustainable future. In the development of our AI solution, privacy and ethical considerations are paramount. As we design a product that interacts closely with users and their personal lifestyle choices, it's crucial that we uphold the highest standards of privacy. Our system will strictly adhere to all applicable laws and regulations. We will ensure that user data is collected, stored, and processed securely, with transparency about how we use this data. Furthermore, in the creation of our AI model, we are keenly aware of potential sources of bias. Our team is committed to identifying and proactively addressing these biases to ensure that our recommendations are fair and unbiased. We will continually evaluate and refine our model to minimize any unintentional bias and to ensure that our product is as inclusive and equitable as possible. By prioritizing privacy and ethical considerations in our design process, we aim to build a product that is not only effective in reducing energy consumption, but also trustworthy. We believe that trust is the cornerstone of a successful AI solution, and we are committed to earning and maintaining the trust of our users.